So today, our lesson is about the history of the Earth. Origin of the universe. The universe began about 14.4 billion years ago. The Big Bang theory states that in the beginning, the universe was all in one place. All of its matter and energy were squished into an infinitely small point, a singularity. Then it exploded. The tremendous amount of material blown out by the explosion eventually formed the stars and galaxies. After about 10 billion years, our solar system began to form. Birth of the solar system. We know how the Earth and solar system are today, and this allows us to work backwards and determine how the Earth and solar system were formed. Plus, we can out into the universe for clues in how stars and planets are currently being formed. The Nebular Hypothesis. In cosmogony, the Nebular Hypothesis is the currently accepted argument about how a solar system can form. Other solar system. We have now discovered over 200 planets orbiting other stars. The processes that created our solar system have also created an uncountable number of other solar systems. The Nebular Hypothesis. A large gas cloud or nebula begins to condense. Most of the mass is in the center. There is turbulence in the outer parts. The Nebular Hypothesis. The turbulent eddies collect matter measuring meters across small chunks, grow and collide, eventually becoming a large aggregates of gas and solid chunks. The Nebular Hypothesis. Pictures from the Hubble Space Telescope show newborn stars emerging from dense, compact packets of interstellar gas called evaporating gaseous globules. Gravitational attraction causes the mass of gas and dust to slowly contract and it begins to rotate. The dust in the matter slowly falls towards the center. Protostar. As a result of contraction and rotation, a flat, rapidly rotating disk forms with the matter concentrated at the center that will become the protosun. False color image of protostar. The multicolored area shows a dust disk surrounding a newborn star. So you can see at the picture, the red-orange area at the center represent the brightest region, which contains the young star. It's surrounded by the cooler, dusty disk, which appears as yellow, green, and blue. The diameter of the disk is about 20 times larger than our entire solar system. The Sun. After sufficient mass and density was achieved in the Sun, the temperature rose to 1 million degrees Celsius, resulting in thermonuclear fusion. So we have hydrogen atom plus hydrogen atom equals helium atom plus energy. Birth of the solar system. The enveloping disk of gas and dust form grains that collide and clump together into small chunks or planetesimal. So as you can see at the picture, we have planetesimals, protostars, the color yellow. Next, we have protoplanets. Gravitational forces allow the inner planets to accrue and compact solid matter, including light and heavy atoms. Solar radiation blew gases, primarily hydrogen, helium away from inner planets. These gases were collected and condensed into the gas giants like Jupiter, Saturn, Uranus, and Neptune. Beyond Neptune, ice and frozen gases form Pluto, Sedna, and the Kuiper Belt objects. Leftover debris form comets and asteroids. Birth of the solar system. The terrestrial planets build up by multiple collision and accretion of planetesimals by gravitational attraction. Giant outer planets grew by gas accretion. So we have at the picture terrestrial planets, planetesimal, giant outer planets, and gas. So we have the sun and the planets. So we have the solar system. At the picture you can see the size of the planets. So we have the inner planets. We have Mercury, Venus, Earth, and Mars. So they are near from the sun. So after the inner planets, we have the asteroid belt. Next is the outer planets. We have Jupiter, Saturn, Uranus, Neptune, and the Pluto. Next, we have Venus, Earth, and Mars. These maps are color-coded to display different elevations on the surface of each planet. So the distance of the Venus and Earth is 2,000 kilometers. The age of the Earth. Earth is 4,570,000,000 years old. Meteorites give us access to debris left over from the formation of the solar system. We can date meteorites using radioactive isotopes and their decay products. As you can see at the picture, we have the geologic time bombardment from space. In the first half-billion years of its existence, the surface of the Earth was repeatedly pulverized by asteroids and comets of all sizes. One of these collisions formed the Moon. Formation of the Moon. The giant impact hypothesis predicts that around 50 million years after the initial creation of Earth,